Welcome to our training on an engineer's guide to PLCs and PACs. We will be starting with an introduction to programmable automate logic controllers, go over Windows CE-based automation, programming with VB.NET, IEC 61131-3 programming, Linux-based automation, C language, ladder logic, SCADA, and we're also going to be including some applications. If you have any questions, please enter them into the chat box and we'll be addressing them at the end of the training. If you're working on any kind of applications you want us to go over, let us know. I'm Maria Santella, our sales manager. I've been with ICP DAS USA for 11 years and was an application engineer here in the past. I have Robert Murao, one of our senior application engineers here with me, who's been with ICP DAS USA for over 10 years and has extensive experience in the automation industry. Later, he'll be giving an online demonstration. I also have here Erica O'Hara, our marketing manager. ICP DAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets. We offer ROHS compliant lead-free products and have our ISO 9001 certification, ensuring we meet product statutory and regulatory requirements. We provide industrial control products and data acquisition system solutions that are low DC voltage and operate in extreme temperatures between negative 13 degrees Fahrenheit to 167 degrees Fahrenheit or negative 25 C to 75 C. We manufacture our products in Taiwan and can ship within about 7 to 10 days on out-of-stock items and can ship the same day on in-stock items. We are a Microsoft Windows embedded partner. We have a knowledgeable team. We provide free application consultation. We can specify products for your projects and provide free technical support. We can help you with questions, setting up equipment, and troubleshooting issues. If you're going to be buying a large volume of equipment, we can provide a configuration service before we ship, which makes installation fast and easy for you. Our products are very reliable and come with a 1-year warranty. We provide free Easy Data Logger software for data logging, control, and monitoring. It runs on a PC. It works with most of our data acquisition equipment, and you can use it with other vendors' Modbus devices as long as you have one of our Modbus devices in the network, or if you purchase the advanced license, which supports up to 1,024 channels, and the free version supports up to 64. In the early 1900s, industrial automation and machinery was done through electromechanical relay circuits, which turned on individual motors. They turned them on and off. Factories had massive cabinets that were full of power relays. The first PLC was invented in 1968 and introduced in 1969 by Bedford Associates. It had 16 inputs, 16 outputs, 1 kilobyte of memory space, and was called Modicon 084. It was their 84th successful project. Bedford Associates then they opened Modicon, a company for manufacturing and selling the new PLC. Around that same time, Modicon created Modbus protocol for use with its PLCs. Other vendors developed PLCs, including Allen Bradley, General Electric, Omron, and others. The automobile sector was the first industry to deploy PLCs into its operations. They wanted to replace thousands of hardwired mechanical relays with programmable controllers. In 1972, the Modicon 184 was introduced, which was easier to program, had greater reliability. Modbus was published in 1979, and it became an industry standard. Early programming resembled relay logic schematic diagrams, which were easy for technicians to understand. In the 1980s, IEC 61131-3 standard for programmable controllers was introduced, making it easier to program PLCs. The 5 compliant programming languages include ladder diagrams, function block diagrams, sequential function chart, structured text, and instruction list. Remote I/O was introduced, reducing the cost of wiring and giving application implementation greater flexibility. Processors evolved, the PLC got smaller, and the cost of PLCs came down. Operator interfaces were introduced, providing a way for operators to interact with the control systems. In the 1990s, the HMI human-machine interface was developed, which helped save hours and hours of time troubleshooting issues with machinery. The HMIs displayed system status, generated reports, provided production count, and alarm information. PLCs have been broadly adopted as the standard automation control system in discrete manufacturing industries. Programmable logic controllers, or PLCs, run one program sequentially. It scans all the inputs, begins the process, processes sequentially, the process ends, it reflashes all the outputs, and then scans all the inputs again, and so on. We offer embedded palm-sized DIN rail mountable IEC 61131-3 PLCs. We also have touchscreen PLCs that are programmable in ladder logic and C language. We also have rack-based PLCs that use I/O cartridges and support the IEC 61131-3 languages. Different variables are used in programs for measurement levels and I/O status. They can be displayed on the screen of the touchscreen PLC or passed to another system over RS-232, RS-485, or Ethernet ports. And Robert's going to be showing you more about that a little later on. Our touchscreen PLCs are programmable in ladder logic and C language. They can work with remote I/O over the Modbus RTU, RS-485, or Modbus TCP Ethernet bus. They can be mounted in external wall mount boxes or outlet boxes in the wall. They have high-resolution resistive color touchscreens, real-time clocks, and a speaker. The VPD series have a DIN rail mount and our IP65 waterproof panel mount. They communicate over Modbus for easy SCADA integration. Programmable automation controllers, or PACs, have an operating system and can run multiple programs. Our PACs with Windows CE.NET 7.0 inside have an FTP server for file and information retrieval, a web server for remote monitoring and control through a web page, SQL for data management and querying of information, the .NET framework for running Windows-based applications, our own ICP DAS VCEP for remote management from any location, and various I/O ports. We also have rack-based versions that use I/O cartridges. Programmable logic controllers, PLCs, and programmable automation controllers, PACs, are widely used in manufacturing, automation systems, machinery, and industrial control systems. PLCs and PACs both utilize protocols and networks, including Modbus, RS-485, Ethernet, ControlNet, DeviceNet, Ethernet IP, Profibus, CAN bus, and more. The PACs have an operating system which allows for running multiple programs simultaneously. Programs can be developed in programs in languages like C#, C++, C language, and VB.NET. PACs have an open and architecture and modular design. PLCs, they can run one program and have a simple sequential program execution. They scan the I/O, they have limited memory, and discrete input and output. Our rack-based PACs have up to 8 I/O slots on board. The WP8821-CE7 has a Windows CE 7.0 operating system and is equipped with a 1 gigahertz CPU. It has VGA, USB, Ethernet, RS-232, and RS-485 ports. The I/O slots can be used with our i8000 or i87 I/O or communication modules. In this application here, you can see that this PAC controller can work with the I/O over the Ethernet bus, the serial bus, the CAN bus, and it also has the I/O slots. We have different variations. Some of them have the 4 I/O slots, and some have the 8. And you can also use I/O racks, and it's very expandable. WinPACs can be connected to other devices like the HMIs and that can be running SCADA software. We also provide free e-logger software for our PAC controllers for up to 50 tags. Allows you to make an HMI. Our PACs have a web server, so you can publish the e-logger software as an HMI to be available over a web page as a user interface for monitoring and control. E-logger has sliders, gauges, buttons, trending, numerical displays, labels, and counter widgets that you can use for displaying measurement and status information. You can also use it with SQL Server for storing and retrieving data. It has a flexible interface called shared memory that allows you to use it with Visual Studio.NET, Win-GRAF, and ICP programs, so you can access the data of the I/O module and exchange other temporary data through shared memory. We also offer e-logger for PCs for up to 30 tags, and advanced licenses are available for up to 4,000 tags. VB.NET is Visual Basic.NET, an object-oriented computer programming language developed by Microsoft that makes it easy to create applications. It was first introduced in 2002, and it runs on the .NET framework, which many libraries and sample programs are available for. It has automatic code formatting, automated garbage collection. It supports Boolean conditions, multi-threading, so you can deal with multiple tasks at the same time. It has event management and Windows Forms, so it's easy to make user interfaces or use existing forms in your projects. It's easy to learn and great for simple applications. One thing it doesn't do is it doesn't handle pointers. So if your program needs them, you'd need to add additional coding, which would add a lot of processing, and so your application would be slow. If you need pointers, I would suggest use C++. VB.NET supports different data types, including Boolean, which is true or false. Char is a single character. Strings are different characters and numbers of different length, date. It also supports date, decimal, and other numerical formats, object, and user-defined structures. An object is code and data that can be treated as a unit. It can be part of an application like a control or a form. An entire application can also be an object. Each object in VB.NET is defined by a class, which describes variables, properties, procedures, and events of an object. Objects are instances of classes. Once your class is defined, you can create as many objects as you need for your project. An example is if a car is a class, then attributes like the fuel level, the speed, and the mileage can be accessed by the object. With VB.NET, you can make applications with or without user interfaces that interact with your I/O. You can use web services to exchange data over networks or the internet. We provide demo programs and DLLs for use with our PCIO boards. The demo programs include sample code that shows how to use counters, take measurement, read digital inputs, and turn outputs on or off. To create a project in Visual Studio, depending on the version you're using, you would go to the File menu and click New Project. There's going to be installed templates. It's a little pane, and then when you expand Visual Basic, you'll click Windows. Then click Windows Forms application. Then you name your application, you click OK. Import statements are used to import names from other projects or from the current project. Adding a new namespace to a project makes the object in that namespace readily available for use in the project. To use our demo programs, you add those import statements to your project, like those shown here, including import system.drawing, import system.windows.forms. Function procedures can declare the data type of the value that the procedure returns, including Boolean, char, string, or object. If you don't specify a data type, it will return an object. Then you declare your classes and you import functions. You design your user interface, and you use DLLs in your application. To use our demo programs, you import the function declaration from the PIO.dio.bas, for example, into your code. The code defines the signal source, interrupt channels, triggers for high or low, IDs, test functions, driver functions, DIO functions, and counter functions for different boards. A class describes variables, properties, processes, procedures, and events of an object. Objects are instances of a class. The methods and variables that make up a class are called members of the class. To define a class, you create a project and you click Add Class on the project menu. You select the class template and you name your class. Then you click Add to Display Code for your new class. You add the code between the class and the end class statements. You can declare fields private, so they can only be used within your class, or you can make it public, providing more access from outside. You can import DLLs and create functions in your class with the code as seen here. You can create if-then type logic rules as shown at the bottom right, and you can run your application by pushing F5. IEC 61131 is the only international recognized industrial automation control language to support all 5 PLC languages, including ladder diagram, function block diagram, structured text, instruction list, and sequential function chart. So ladder diagram, function block diagram, and sequential function chart, those are graphical, and structured text and instruction lists are textual. Ladder diagram or ladder logic is a widely used programming language based on circuit diagrams of relay logic hardware. It's used to develop software for PLCs, and the programs resemble ladders with 2 vertical rails on each side with horizontal rungs between them. The ladder rungs get executed sequentially. Ladder logic looks like a ladder, and it's used to implement logic, which is where it got its name. There are input contexts on the left, leading to output coils on the right. It uses Boolean true or false, on or off logic for digital inputs and outputs, and the analog values are variable. Ladder logic supports function blocks that do calculations or operations. With a direct contact on the state, the state on the right is a logical AND between the state on the left and the value of the variable associated with the output contact. With an inverted contact, the state on the right is a logical AND between the state of the left and a Boolean negation of the variable associated with the contact. To program an OR operation in your ladder logic program, you would make a parallel input or output where if either is open, the output would be energized. In a truth table for a Boolean OR operation, you can see 0 or 0 is 0. 1 or 0 is 1. 0 or 1 is 1. And 1 or 1 is 1. Structured text is a high-level programming language similar to traditional coding. It's textual based, unlike ladder logic. All statements end with a semicolon. Routines are closed out with an end if statement. Structured text is not case sensitive. The comments are closed with parentheses and stars, like the green text in the parentheses showed here. Structured text uses logical operators, including and, or, and not, to manipulate the data using Boolean logic. This program here sends a string every 2 seconds from the PAC COM1 port. If it's initialization and the very first cycle the system is run, then init turns to false, so the next cycle will be noted as no longer being the first cycle. You can program in IEC 61131-3 with our Win-GRAF development software on new Windows operating systems. Win-GRAF supports up to 10,000 tags. The development environment has a menu and toolbar at the top, a workspace on the left for initializing and making variables and adding programs. The program area in the middle is where you develop and work on your programs. You can assign variables to your functions in your programs. There's also a message area at the bottom for debugging. Linux is an open source Unix-like operating system based on the Linux kernel. We offer PAC controllers with Linux operating systems. These are widely used in the oil and gas industry. Some of our LinPACs, like our LP5131, have a 520 megahertz CPU, and it runs Linux kernel 2.6.19. Our LP9221 has Linux kernel 3.2.14 with a 1 gigahertz CPU. We provide a Linux software development kit and Java API with our LinPAC controllers that helps get you the status of your I/O, helps you set alarm limits, gets the counter values, set values, and more. Our LinPAC controllers have web, FTP, Telnet, and SSH servers. They can be programmed in C language and Java. They have Perl and PHP interpreters. They can be used with MySQL databases, have USB, audio, microphone, Ethernet, RS-232, and RS-485 ports. They come with a micro SD card, and the different versions, some support up to a 16 gigabit card and some support up to 32, a micro SD card. Our Linux programmable automation controllers are being used for highway traffic flow monitoring. The LP8381 PAC controller and the I-8057 digital output module and the I-8053W digital input module are being used to monitor vehicle speed and control traffic signals and switches. The I-8053W digital input module transmits inductive loop detector signals over Modbus RTU, which provides traffic flow data. USB web cameras are connected to the LinPAC to show live video footage in the system. The I-8057W digital output module is used to trigger traffic signals and on and off signals. So again, PACs have an operating system. They can run multiple programs simultaneously. You can use one program for control, one for monitoring, one for data logging, and one for remote access all at the same time. They're good for expandability. So as an application grows in the future, you can add more and more features. PLCs can run one sequential type program that's usually programmed in ladder logic or C language, and you can use PLCs together with PACs. So this is our HMIWorks development environment. It's used with our touchscreen PLCs like the TPD series and the VPD series. It has the standard workspace with the menu bar at the top, workspace and toolbox on the left for adding files, tags, devices, and I/O. The frame design space in the middle is what you will actually see on your touchscreen once you load it into the controller. And you can add graphics there, labels. You can show different measurement levels on the touchscreen. The inspector and libraries on the right is where you can modify attributes of items you put on the design space, like the color of a button or the text font and all that. There's a results window at the bottom for showing outputs and errors for debugging. On the back of the actual touchscreen controllers, there's these little rotary dials. And so that's, you would turn it to the right mode for program upload, and then you would turn it back for the run mode. C language is a popular general purpose procedural programming language. It's a structured language, similar to structured text, and it's easy to learn. You use a compiler program to convert your program into an object file that's readable by a machine. After compiling, the linker combines object files, creating an executable file to run your program. C language is case sensitive, supports functions, and is text-based, so it's easy to read. The programs include variables, functions, statements, and expressions. Some basic commands include the input and output header files from the C library. Before compiling a C program, you can add other header files, libraries, and functions in a similar fashion in your program. The main function is a part of every C language program. The empty parentheses next to void main indicate the function doesn't return any value or parameter. The printf function generates the output of the text hello world. The semicolon indicates the end of every statement. Every statement must end with a semicolon. If you don't put it there, you're going to have a problem. Variables are dedicated before being used in your program. They have to be made with characters, numbers or underscores. They cannot begin with a number and can't have any white space in them. Variables can be used to store value. Constants don't change in value. C language provides some data types, including int for integer data, char for character data, float for floating point numbers, double for double precision floating point numbers, and void. Character constants are a single character in a single quote. String constants can be words or lines of text in double quotes. If statements allow for the flow of the execution of a program. An if statement is always used with a condition. The condition is evaluated before executing any statement in the body. If the condition is false, the instruction will not get executed. The condition evaluates to either true or false. True is always a non-zero value. This program checks the equality of two numbers. Robert's going to be showing a demonstration of using SCADA, supervisory control, and data acquisition software with PACs and PLCs. SCADA software runs on a computer or PAC controller like our IWS 4201-CE7. SCADA software allows for monitoring of measurement levels like tank level, pressure, temperature, pH, turbidity, and the visualization of those measurements on a screen. Data is passed over Modbus TCP or Ethernet cabling. I/O modules communicate over RS-485 as shown here. Robert will be showing how to use Modbus RTU and Modbus TCP protocols to share data to an AVEVA Edge SCADA system. The data can be used to create an HMI, monitor and control an entire production environment. These are some sample SCADA screens here. You can see here that you can display and visualize the oil pressure. And also there's a button here that you can push for the on or off of the drilling process. You can see there's also a tank manufacturing system where you can see different tank levels and measurements. You can use a Google API and you can use that with your SCADA software to see the location of different elements in your application. We have a Modbus RTU based GPS module, and that's how you'd be able to transmit the data over Modbus RTU and see the GPS location on a map like that. And then this other picture here is the monitoring of a solar plant, so you can see the energy production from the different systems. So now Robert, I'm going to pass the presentation over to Robert. And again, if you have any questions at any time, please enter them into the chat box. And then Robert's going to be
Okay, thank you, Maria. Let's see, let me share my screen. Let's see, can you all hear me okay? Maria, can you hear me okay?
Yes, I can hear you fine.
Okay, let's see. So today I'm going to show you the AVEVA Edge software. AVEVA Edge is a standalone PC or Windows-based software package. Traditionally, it runs on PCs, but can also run on embedded systems like Windows Embedded Standard or Windows CE machines, like some of our PACs. Some of our modules or PACs come with AVEVA Edge or InduSoft pre-installed. AVEVA Edge can be used for HMI screens, controls, or overall control or data monitoring. Today, I'm going to show you how to use Modbus protocol to share data to a SCADA system. So no matter what PLC you have, well, I guess most PLCs nowadays allow for communication to other equipment like HMIs or SCADA systems. The idea of this is to allow for control through like a HMI where it's a touchscreen, or you can data monitor or do supervisory control or combine equipment. For systems with like, say, a packaging machine, The packaging machine is controlled by a single PLC, but the packaging machine is also tied to, say, a production machine for raw equipment that goes into the packaging. So therefore, you can control and see both systems using communication through a SCADA system like AVEVA Edge or Indusoft. Let's see, for the example today, I'll use Modbus RTU and Modbus TCP and show you how to connect to read values from a PLC. The idea is the PLC would have Modbus capabilities. Nowadays, a lot of PLCs do, but if they don't, we can help you with the hardware on our side as well. And finally, I'll show you how to use SCADA to monitor and control an application. So let's see, this is a slide from Maria's with one highlight. So this is the portion that I'm going to go over today, the HMI and SCADA software. So these show WinPACs and PLCs that control specific equipment or specific applications. What SCADA can do is either create an HMI on the local environment for controlling the machine through an HMI, or it can be used for combining multiple PLCs or PACs data and viewing it in an overall screen so you could see what's happening throughout the whole production environment. Let's see, in this diagram, we have our Decon and Modbus RTU slave devices being controlled by the PLCs or PACs for control of the local application, but the HMI and SCADA software is used for data logging and HMI controls. Here's another snapshot of it. So basically you have one WinPAC controller in the middle. It's being controlled and monitored using an HMI. SCADA can also be used to data log. Another SCADA system can be used for showing the control plant, what's happening in the system, and various other functions and features. But essentially multiple connections using either serial or Ethernet connections to the PAC will allow you to control, monitor, and do other functions from the data from the Win-GRAF PAC that's controlling the application. Here's an example of like local control. So this is just a simple oil well monitoring the pressure and flow of the oil well. On the right side would be a trend curve showing the pressure and the flow and making sure that everything is working within standard parameters. The drilling process is signified by a red button-like icon, and it would turn green when it's off probably. And basically it indicates if the process is happening. Now imagine if you had multiple oil wells, or if you had multiple locations with multiple oil wells, then you can incorporate a SCADA system to envision or display the values of all the oil wells in one specific system or one combined system. Here's another example. In manufacturing automation, this is an example of a conveyor application with flow and monitoring. But imagine if after the cans are produced and filled, they go onto the packaging machine. So the SCADA system can communicate with this system, bring in the data, monitor for stoppages. If stoppages occur here, they can either slow down or stop the packaging process to accommodate the down line in the can processing. In this example, the HMI shown in the top left is used to control and monitor the whole system. So in this case is a wastewater site and a tank site and a control center. So each site can have its own controls and HMI running SCADA, but you can also have an overall system. So using communication, in this case using Modbus TCP IP or RS-485, you can connect to a central system or two external devices running SCADA software, and they can all show different snippets of the application. So for instance, maybe on one, this PAC right here can just monitor and control the tank process. But it can also share data with the main control system or the control center to, let the other locations or sites know what's happening in the application. And, if controls need to be monitored, slowed down, or processes need to be stopped or for maintenance, they can be adjusted. So today for the Modbus TCP application demo, I'm going to use these parameters. I have a PLC with the IP address of 21.127.129.230. It's port 502 is the data port. That's pretty much standard for Modbus TCP, and the address is 1. The registers I want to monitor are just 30,000 and 30,001, which are analog input registers. And we're just going to connect that to our SCADA system for monitoring. This would be symbolic of data from a PLC or data from a PAC that is running an application. Sometimes sensors can even communicate using Modbus TCP, Modbus RTU, or another protocol to share data. So for instance, like a wastewater treatment, you want to make sure the flow is still happening. So if the flow is, stopped at one location, then there's a clog or a broken pipe or something that you want to definitely shut down the the valve that allows the flow to go through. Secondly, we will create a Modbus RTU connection, which is a serial-based connection using these parameters. In this case, the main ones we need to know are Modbus RTU protocol. The slave address of this particular module is 1. The data format's engineering, and let's see in the next table, this one has the register information. So from the previous slide, we have COM port 4, which is what is connected to the PLC, the baud rate 9600 N81, and Modbus slave ID of 1. And then the registers we're going to be monitoring are 30,001 to 30,006, which are analog inputs, and 40,033 and 34, which are analog outputs. So now comes, oops, let me find it, AVEVA Edge. Okay, this is the AVEVA Edge work environment. Right now I have the demo running, so I'm just going to create an application. So the first thing we want to do is create our connections to our devices. So we use the COM tab right here. And then the driver we want to use, we're going to use 2 drivers in this case. The first one being Modbus RTU. Let's see, MO. Modbus RTU, which is here. Notice the protocol pops up down here, and we will also use Modbus TCP for this application. So we're using both drivers here. They both show up down there. Then we click OK, and then we can expand this tab, and we see both drivers. The first one I'm going to do is Modbus RTU. The first thing you must do with Modbus RTU is create your connection to the device. So I want to again note that from the previous slide, it showed COM4, 9608, N, and 1 is our communication settings. So we click OK there. Then we need to edit the main driver sheet. With this one, this is where we create our tags, create our association between the data at the PLC, and create a tag for within the SCADA system to view and manipulate the data. So for this one, I'm going to, let's see, it was an analog input, analog output, and maybe we could do a few of each. So let's see. So what I need to do here is, let's close this. That was a mistake. Double click by mistake. So let's put M, just so we know it's RTU, MR for Modbus RTU. And then we'll call the tag AI0. And then it'll ask you if you would like to create the tag. We'll go yes. And just follow the defaults for this example. The station ID is 1 that was shown in the previous slide. That's the slave ID of the individual PLC or controller. And the IO address, in this case for the analog input, is 3x:1. And then we'll create a second one for analog output, MR for Modbus RTU, and then AO0. And then station ID is still 1. We'll create the tag. Yes. And this time, instead of 3x, it's 4x, colon 1. And we click OK. The next thing we'll do is, well, let's add one more analog input tag. Oops, keep double clicking by mistake. MRAI1. Let's just do that. And following the Modbus address table, the AI would be 3x colon 2. Notice this is 0, this is 1, but it's 0 and 1, then 1, then 2. If we had a AI2, it'd be 3x colon 3. Okay, and these are actually read only, so we'll just make them read. You don't necessarily need to do this. The hardware itself limits it anyways, but just for being correct, I will do it here. And then secondly, for the Modbus TCP connection, this is the second connection. We need to edit the main driver sheet, create our tags. So this one, we'll call it MT for Modbus TCP, and this one's only analog input, so AI0, and the station is the IP address, followed by port number, followed by Modbus ID. So in this case, it'd be 21.127.198.230 colon 502, which is the Modbus port, and then colon 1, which is the slave ID. Okay, and then the address for the data is 3x colon 1. If you do need more information on this, it's available in the Modbus register table. If you need help in creating your first few tags, give us a call. We can help you to create them. This is just an example for showing connectivity and communication between devices. So in this case, we've created our connections using Modbus RTU, Modbus TCP. The next thing we'll do is create a graphical display where we can see the values and control the values. So we'll go screen here, create a new screen, insert screen. Let's just call it main, and then click OK. And this is the design environment right here where we create our HMI essentially. Okay, so the first thing I want to do is label some text. Let's call it Modbus RTU, and then we'll call something over here draw text Modbus TCP. I forgot the space. That's okay. Then we will use a text box to just display the values. So the first one we had is AO0. We can double click within the box and pick the tag which is associated with it. So first I'll pick the analog input value, which is shown here, and just display that. Then we'll do a second one to display the second value. Again, just double click and get the properties, and then use the 3 dots over here to select the tag which is associated with it. So we had 2 analog inputs, and then we have a third analog input, which I will show here. Okay, and then finally, we'll do the same thing for the Modbus TCP value. Oh, I'm sorry. To click and click here, and we will pick the values. Okay, also what I want to do is create a slider which will be used to control one of the analog outputs so that you can see it in operation. Let's choose this one right here. Let's see the sliders associated with this one, I believe. And to choose the tag, we double click on it. Properties, I think it was between 10,000, 10,000 and 0. And then we need to pick the tag name, which, oh shoot, I forgot the tag name. What was the tag name? It was MRAO0, if I recall right. We'll find out in a minute. And let's just run the project to make sure that everything is set up properly. Let's save all. Save yes, and run. Let's see if the values change. Okay, this value is changing. We're reading values on all the connections, so everything is showing okay. Okay. Next, we'll go back here and we'll, stop the project. It's better if you add exit buttons, but for this example, I just want to move on. Okay, the next thing I want to do is show, let's see, a trend curve so you can monitor the application. Oops, let me go back here. Screen 2. Okay, so draw. Where's my trend curve? There we are. I'll just use the predefined trend object in InduSoft, or AVEVA Edge rather. And with this trend curve, you can create your own page for it. Let's just actually move stuff so we can have more room for it, have it bigger. And again, it's a WYSIWYG drawing environment, so whatever you show here is what will be shown on the screen itself. And it's everything within the parameters shown here. So then to edit this, we select the points. In this case, we'll just call it, say, temperature as a label, temperature, and the tag field will be the tag name. And then let's see, let's call the second one level, the third one flow, and so on. And then we will add the tag values, double click, double click, double click, and let's just add, call it pressure. Let's just add all the tags that we have here and we click OK. Only thing we might have to do is adjust the axis values. I think we have 10,000 is the highest, so we'll do that. Create the object, let's run this, see how it goes. Notice down here you could see the values happening. You see straight lines pretty much happening, but if I adjust the slider, we can see the actual value being shown in the trend curve live. So we'll just stop it there. Now it should go flat. Then we could move it back and you could see it moving again. Okay, so using a SCADA system, you can create a nice HMI, or you can create a project which can visually show you the status of your application or a whole process of within an application. Let me just go here now. And I've shown this before, but I do like to show some examples of what you can do if you actually spend some time on this. And you can use your tags and communication from your PLCs and PACs to create a nice application where you can see what's happening and control your application. So right here, I just like to show the industry examples. So these are just simulations of what you can do within AVEVA Edge or InduSoft. They're both practically the same thing. AVEVA Edge is the new name of InduSoft. So some customers who've previously purchased our hardware might know it as InduSoft, but the updated name is AVEVA Edge, and it's just a rebranding of the product. If anyone has any questions, I'll answer the questions.
You can also purchase older versions of InduSoft, so it's not completely rebranded. If you have 7.0 or 8.0 systems, you could still buy licenses for those systems, and it is still supported. If you have any questions, please enter them in the chat box. Otherwise, you can always email us or call us, and we will be happy to help you.
Okay, I do show one question. Let's see. Does your product support the BACnet protocol? We do have converters and gateways which support BACnet. There's also industry examples for BACnet communication to Indusoft and AVEVA Edge. So yes, I do believe BACnet is covered. And
yes, we have a BACnet IP to Modbus RTU gateway. We also have a BACnet to Modbus TCP.
And we have both BACnet IP and BACnet serial as well. Any other questions? Okay, I don't see any other questions, but if you do have questions afterwards that you think of, you can always give us a call, send us an email, or you can contact us by our web chat. We appreciate you coming and spending your time with us today and look forward to seeing from you next month.
And I'll be sending you an email with some information from the webinar. And if you have anything we can help you with, just let us know. Thank you for attending the webinar. Bye-bye.
Okay, bye-bye all.